All right, this is section 4.1, quadratic functions, part 2. Our next exercise. The revenue R from making and selling tiny tooth decals can be modeled by the equation R of x is equal to negative 6x squared plus 114x, where x is the number of decals in hundreds. Sketch the graph of the quadratic. I'm going to go ahead and use the calculator for this. Let's see here. So we want negative 6x squared plus 114x. I'm going to go to the y equals button here to put a function in. Negative 6x squared plus 114x. Okay, let's see, what am I, I don't know what the window settings I should use for this, so let's just use Zoom Standard 6. Okay, it looks like we're going to need to change the y-axis scaling a great deal. So let's go ahead and do that. And at the same time, well, let's change the y scale. So we go to Window, and we'll change, let's see, y min to say, well, I know this is a parabola that opens downward, and I know one of the zeros is at, because I can factor in x out of both of those terms. So I know we should really go from 0 up to something on the x-axis, and then the y-axis also we should go from 0 to something like, I don't know, maybe 500, we'll just say. So let's try graphing that. Okay. Yeah, we should go a little higher, maybe to 600 or 700. And we only need the positive side of this because we're just talking about revenue, so it doesn't make sense to have negative quantities of sales. So let's change the x to 0 to say 20. And we'll go up to 600 on the y, and maybe do a y scale of say 50. All right, there, that looks good. Okay, I can trace that. There we go. So there's the graph, and the x-axis goes from 0 to 20, and the y-axis goes from 0 up to 600. So that gives you a scale, a feel for the scale. And I want to take this picture and, whoops, just drag it right into here. Okay. And there we go. Let's move this and maybe make it bigger. Okay. Part B. How many tiny tooth decals need to be produced in order to maximize revenue? And what is the revenue? Okay, so here we need to remember how to find what we want to do is get the vertex point. That point at 10,540 is probably pretty close to the vertex, but it's not exactly at the vertex, I would bet. So we want the vertex h comma k. Okay, and what do we need to do to get that? We need to remember the formula for h. H is negative b over 2a. So here is a, and here is b. c is just 0 with this quadratic function. So let's see, what do we get? We get negative 114 over 2 times negative 6, that's negative 12, which is, I'm going to do that on the calculator. 114 divided by 12, so what about 10-ish? 9.5, yeah. Okay. So when x is 9.5, we will get the highest point on the parabola. But what is that highest point? Well, to get k, we have to evaluate our function at h. So we want to, our function is revenue, so we want to evaluate r at 9.5. Okay, so this is going to be negative 6 times 9.5 quantity squared plus, what was it, 114x? Plus 114 times 9.5. Okay. Definitely going to use the calculator for that calculation as well. So let's see here. We want to do negative 6 times 9.5 squared plus 114 times 9.5. Is that correct? That looks right to me. Okay, and we get a k value of 541.5. Okay, so then our coming back now to OneNote. Let's see, did we answer the questions? How many tiny tooth decals need to be produced in order to maximize revenue, and what is the revenue? Okay, so we're going to remember that this h and k, these are x and y values, right? And x is the number of decals in hundreds. So it's not just 9.5 decals that we got to produce and sell. We've got to, the way you should think of it is quantity is 100 times x, because we're measuring x in hundreds of decals. So to get the actual quantity, you multiply the x value by 100. So the quantity we need to sell is going to be 9.5 times 100, which is that's 950, right? Move the decimal place over 2 places. There we go. So we got to sell 950 decals, and when we do, our profit will be 541.5. Is this well, it doesn't say what the units are of the y coordinate, but maybe dollars. Okay, so there we go. You've got to sell 950 decals to make $541.50 in profit. Okay, next, find the quantities at which there is zero revenue. So the idea here is we want to set revenue equal to 0 and solve for x. And remember, what was r of x? It's this function, negative 6x squared plus 114x. So we have negative 6x squared plus 114x equals 0. That's the quadratic equation we want to solve. I can factor this. So let's factor. When factoring, we typically will factor as much out as we can from the quadratic term. And I'll be left with x minus, let's see, 114 divided by negative 6 is going to be 114 divided by -6, -19. So yeah, x minus 19 here. And so we get either x equals 0 or 19. Okay, yeah, and that agrees with our graph, doesn't it, from above? Yeah, this was this point right here is 19. This end point, and this is 0. Okay, so yeah, our revenue will be 0 if we sell 0, and again, it will be 0 if we sell 19. Oh, but really we need to, it says find the quantities at which there is 0 revenue. So really what we need to do is now convert this into hundreds. We got to multiply these two numbers by 100 to get the true quantity. Q is equal to 0 or 1900. Okay. Give the quantity interval where the revenue is greater than 0. Yeah, so this would be this interval from 0 to, and it's a quantity interval, so we want to 1900. Okay. There we go. Any other questions? No. Okay. Next exercise. The demand equation for a certain product is given by P is equal to 128 minus 0.05x, where P is the unit price in dollars of the product and X is the number of units produced. Recall that revenue is obtained by producing and selling X units and is given by R is equal to X times P, where here P is price. The number of units you produce and sell times the price per unit. Okay. Part A. What quantity will produce a maximum revenue? Okay. So first off, we need to get our revenue function. What is the revenue function? Well, we're reminded that revenue is equal to X times P. But we have a function for P, which is a function of X. So this is going to be X times 128 minus 0.05x. Okay, there's our revenue function. That's in factored form. I could multiply it out though, and I would get what? When I distribute this x to both terms in there, I'm going to get a negative 0.05x squared plus 128 times x. All right. So we have our revenue function, and we want to maximize it. How do we maximize a quadratic function? We compute this, the HK, the vertex, right? Which we label with the symbols HK. H for the x component of the vertex and K for the y component of the vertex. So this will just be negative b over 2a. So here's this is b. This coefficient, that's a. So we're going to have negative 128 over 2 times negative 0.05. What is that? So I have negative 128 divided by parentheses 2 times negative 0.05. Close those parentheses. Okay, it looks a little funny, but yeah, that's correct. So enter. So we get 1280. Okay. So there we go. What quantity, and this function measures revenue just in units, not in like hundreds of units or thousands of units. So that is our answer for part A. So in order to maximize revenue, we need to produce 1,280 units of this product. Part B, what quantity will produce a revenue of $100,000? Let's see here. So we want to set the revenue function equal to $100,000 and solve for x. Whoops. Let's hide you. So we want to do negative 0.05 x squared plus 128x equals 100,000. Okay, so that's the equation we need to solve. It's a quadratic equation, and to solve it, first we want 0 on one side of the equation, so let's see, I'm going to move everything over to the right-hand side of the equation and then flip it. So when I do this, I'll get 0.05 x squared minus 128x plus 100,000 equals 0. Okay. I do not want to try factoring that to solve it. I think I will use the quadratic equation. Okay. So recall the quadratic equation is well, actually, this is a good tip. Whenever you need to solve the quadratic equation, you should compute the discriminant first. Now remember, the discriminant of the quadratic equation is that part underneath the square root symbol. It's the b squared minus 4ac. You're going to have to compute that value anyway. You might as well compute it first. Why? Because it tells you something about the zeros, okay, of the solutions to the equation. So let's compute the discriminant, and let's see. We want to compute b squared minus 4ac. Let's see, what is this going to be? So b, well, so here's my b now, this negative 128. Here's my a, and here is my c. So b squared, that's going to be negative 128 quantity squared minus 4 times a, which is 0.05 times c, which is 100,000. Okay. Well, let's do this on the calculator. So I'm going to do, well, negative 128 squared. It's the same as 128 squared. So 128 squared minus 4 times 0.05 times 100,000. Is that 100,000? Yeah. Okay, that looks right to me. Oh, and this is negative 3616. And this tells me something very important. This tells me that this equation has no real solutions. Why? Well, because the discriminant, if the coefficients of your quadratic equation are real numbers, which they are here, then b squared minus 4ac will be a real number as well. And that number, there's three possibilities for that number. It could be positive, which means you're going to have two distinct real coefficients. It could be 0, in which case you have a repeated 0, like a double 0. Or you could have a negative number. Any real number has to be either positive, 0, or negative. And so in that case, though, you get complex conjugate zeros. Okay, so in other words, no real solutions. So this has no solution. Our revenue, in other words, will never be $100,000. So we could just write no solution. The revenue will never reach $100,000. Let's confirm this by graphing it. Okay, so really what I want to do is I want to check when will this function be equal to 100,000. So I'll just plot both of those functions. I'll do negative 0.05x squared plus 128x. Okay. And let's see. What should our window settings be? So we got to go like twice 1280. That would be 2600. We'll do it. 2600. And then maybe units of 50. And then y should go from 0 to 100 and maybe 10,000. 110,000. Maybe in units of 10,000. Okay, let's graph that. Yeah. So we see here in the graph, the red graph is just the constant function 100,000. The blue graph is the left-hand side of our quadratic equation. It's the negative 0.05x squared plus 128x. And notice it never quite reaches 100,000. Our revenue will never quite get there because our revenue maxes out at about, at 1258, so right at around $81,900 in revenue. Okay. Okay, we have one more exercise here. Let's see. A coffee shop sells 420 lattes a day at $3.25 each. They tried raising the price by 25 cents and found that they sold 60 fewer lattes a day. Okay. Assume that the number of lattes they sell in a day is linearly related to the sale price, P, in dollars. Find a function for the number of lattes sold in sub P. So the key linearly related, that tells us that this function in the number of lattes as a function of price should be a line. That's what linearly related means. So how can we get the equation of a line? Well, certainly one way is if we know 2 points on the line. And we actually do know 2 points on the line because they tell us that, so we need 2 in comma, rather P comma N, right? The P is the independent variable. Price is what we have control over, and then the number of lattes sold depends on the price. So P is the independent variable and N is the dependent variable. And so we need 2 P comma N pairs. And well, one of them we know is that we sold at the price of $3.25 each, we sold 420 lattes. Okay, and then we also know that when we raised the price by 25 cents, we sold 60 fewer lattes a day. So raising the price by 25 cents would bump it up to $3.50 per latte, and 420 minus 60 would be, let's see, that would be 360. So we only sold 360 lattes on the day when we bumped the price up. Okay, so now I have two points. I'll call this maybe like P sub 1 and N sub 1, and maybe this is point 2, so I'll label this P sub 2 and N sub 2. And let me make this bigger. There's no need to keep this so small. And now I need to get the equation of the line. So I'll use the point slope form, but before I do that, I need to get the slope. So m is going to be the change in the dependent variable, change in n, divided by the change in the independent variable p. So this change in n, remember delta n, all delta for difference. This means n2 minus n1. So we have 360 minus 420 over P2 minus P1. So that's $3.50 minus $3.25. Okay. That numerator is negative 60, and the denominator is 25 cents, which is, what is that? Let's use the calculator. So negative 60, oh, whoops. Let's quit out of that. Clear that. So we have negative 60 divided by 1/4, or 0.25. I could have done this in my head, but negative 240. Okay, so that's the slope of our line. Okay, so now we know the slope of the line that relates price to number sold. Now we need to plug that slope and a single point, maybe 0.1, into the point slope form, which in this context would have the formula, the dependent variable over here on the left minus the coordinate of the dependent variable is equal to the slope times, in parentheses, P minus P1. Okay, so n minus n1, this will be n minus 420, is equal to negative 240 times P minus P1, which is 325. Okay, I just need to simplify this a little bit now. And what do I get? I get n minus 420 is equal to negative 240p, and negative 240 times negative 3.25. Let's do that. That's 240 times 3.25. That's 780. So that's going to be plus 780. Okay, now I solve for n by adding 420 to both sides. Let's see. And that's going to give me negative 240p. And let's see, 780 plus 420. That's going to be 0, 0, 1. That's 1200. Plus 1200. Okay, so that is our linear relationship between price and number of lattes sold. Okay, notice it works as you would expect. If because the slope is negative, if the price increases, the number of lattes you're going to sell is going to go down. That makes sense. But by the same token, if the price decreases, the number of lattes that you're going to sell will increase. So we have this, it's an inverse relationship between P and N, price and number sold. Okay, part B here, revenue. The amount of money the store brings in before costs can be found by multiplying the price per cup times the number of cups sold. So find the revenue function R as a function of P price. So we want revenue as a function of P price. And again, they tell us is that revenue is obtained by multiplying the price per cup times the number of cups sold. So in other words, R, revenue as a function of price, is going to be the price times the number of cups sold. But this is in as a function of P. It also depends on price, doesn't it? So let's expand this out. So this is going to be P times negative 240 P plus 1200. All right. So there's our revenue function. Let's write it in standard form, or what? General form. We get negative 240 P squared plus 1200 P. Okay. Find the value of P that will maximize the revenue. What is the maximum revenue? Okay, we need to find, this is a quadratic vertex. The lead coefficient is negative, so it opens downward. So we need to find the top point on the parabola or the vertex, and that will be the maximum. So we compute H. Remember that that vertex will have coordinates h comma k, where h is equal to negative b over 2a, which in this case my b is 1200, so we want negative 1200 divided by 2 times negative 240, which is going to be 1200 divided by 480. I'll use the calculator for that. 1200 divided by 480. 2.5. And it also asks us to find what is the maximum revenue. So what we need to do now is compute the revenue at h equals 2.5. And this will give us our k. So what is this? Recall that h is this negative 240 times p, which is 2.5. So at a price of $2.50 per latte, we will maximize revenue. And the revenue will be equivalent to this expression. Okay, I'm going to evaluate that with the calculator. Negative 240 times 2.5 quantity squared plus 1200 times 2.5. Is that correct? Looks good to me. 1500. So, and I believe this was in dollars. So $1,500 in revenue from lattes. Let's see. Yeah, so they were selling lattes for $3.25 each. And they found that they sold fewer lattes every day if they lowered the price. But they're not lowering the price too much here, are they? But that was enough of an experiment to give us some data to be confident that we can lower the price even more, down to $2.50 per latte. And at that price, we should get a revenue of about $1,500. Well, according to this formula, exactly $1,500, but of course it won't be exactly that in real life, will it? Okay, so $1,500 in revenue at a price at P equals $2.50. Okay, and that concludes section 4.1, part 2.